Okay, so we're going to go ahead and begin standard deviation today. That should pretty much take care of this week. Of course, with the test on Thursday, I would be looking for the exam to have frequency tables, histograms, box and whisker plots, the cumulative frequency. I don't believe I put a standard deviation problem on there. So more than likely next week, probably Tuesday, Wednesday, we'll probably do some kind of exit ticket or a quiz on that. But if you have any questions regarding the test, let me know. You still got a couple of days to come on in, 7:45 to 8:05 every morning. What is due tomorrow if you've not already turned those in?
The math IA tomorrow, right?
Well, that is due on Thursday as well. We're going to get there. But tomorrow is going to be those little slips, the focus activities. Okay, we only have 3 of them. Again, if you've misplaced or lost one, got them right over here on the different days that I've given those out. That should be just hopefully a guaranteed quiz grade, but if there's any issues, let me know. Hopefully I haven't run out. But then on Thursday, your IA topic is due. So when you come in, more than likely there's going to be a little notice up on the board that says, please put your cell phones to the front because we're about to take our exam. Go ahead and turn your IA topics into the tray. Does anybody need another one of those documents? Okay, bless you. Did my, yes ma'am. You need another one of those? Okay. I believe got one right here. There you go. Right over there. There we go. So let's see here. As far as that goes, if you have any questions, let me know. Some people have already come talk to me about their IA. Really, this is just more than anything designed to get you thinking about it, because I think the sooner you get started, the better off you're going to be. You definitely don't want to wait until after Christmas or something to go ahead and finally start taking a look at your IA, collecting data, things like that, because then you're only going to have a couple months before it's due. Okay. Let's see. Oh, did everybody get my text from yesterday? Okay. All right. So did anybody go on and take a look at those IAs I posted? I think I posted 10 of them. Is that correct? That's a lot. I mean, I've still got a few more that I can post, but that gives you a better idea. The one that's annotated has some individual from IB went through, and the 7 criterias that you were given, criterion, I guess if that's it, they went through, they labeled where it applied to that specific criteria, and then the comments for that particular example shows you what they made out of 20, the points per criteria, and so forth. So it gives you a much better idea. And you'll notice there's a wide range of topics there. Okay, some that are getting more difficult and some that are just a little bit easier. All right. So I guess unless there's any questions or concerns or anything. Okay, let's talk about standard deviation. So we'll start with a pretty simple example before we get to the main notes. It says the standard deviation is a measure of how spread out numbers are. Its symbol is sigma. That's the lowercase sigma, the Greek letter. The formula is the square root of the variance. Okay, so part of what we're going to be finding is known as the variance. Well, that's the average of the square differences from the mean. And you'll see why I'm describing it as such when we get into the problem. But once you find the variance, if you take the square root of that, that's what we have standard deviation. Okay, so it's the square root of the variance. And if you square the standard deviation, you get right back to the variance. So you're going to notice that in notation, especially next week when we start looking at the normal distribution of bell curves. So let's see. To calculate the variance, you follow these steps. Work out the mean. That means we want to follow the average. So I'm going to take the total of all the elements I have in my set and then do what?
Divide them by the amount of elements.
Divide by the number of elements in the set, okay? So once I work out that mean, the average, for each number in the set, subtract the mean and then square the result. This is what I referred to a moment ago as the square difference, okay? Then work out the average of those square differences. All right, so let's see what we got here. Here's my example. You and your friends have just measured the heights of your dogs in millimeters, because that's a normal everyday activity, right? You just get together with a bunch of your friends and measure your dogs? Yeah. Okay. I don't know, maybe it seemed kind of rough to me, but no, rough. Yes. Okay. Moving on. So here is what they determined. The heights at the shoulders are 600, 470, 170, 430, and 300 millimeters. Okay, so we want to find the mean, the variance, and the standard deviation. Remember, once you find the variance by taking the average of those squared differences, okay, take the square root of that, then you actually have what we call the standard deviation. It's a measure of spread, okay? So typically the way this works, and we'll go into it in a little more detail once we get to the full notes, but the larger the standard deviation, the more spread out your elements are going to be in your set, and vice versa. Okay, so let's go ahead and find the mean. So like Eli was helping me with, I'm going to take the average. So 600 plus 470 plus 170 plus 430, finally plus 300. Okay, and I'm going to divide this by 5 because there's 5 dogs here. Okay, so somebody help me out. What's the sum of those 5 numbers? Okay, 1,970. Okay, we're going to divide that by 5. Okay, 394. So that's the average height in millimeters. Okay, so I'm going to go ahead and use that to help me determine what the variance and then what we call the standard deviation is. So first step, easy, right? Super simple. Find the average just like normal. Well, now calculate each dog's difference from the mean. Okay, so that means I want to take each of these elements in the set and subtract the mean. And it does not matter if it comes out negative, because what's going to happen? We're going to square them. We're going to take the difference and square it, so you're always going to get a positive result anyway. Okay, so negatives do not matter. So I'll just take these one at a time. So 600 minus 394. That's going to give me what? Okay, 206. 470 minus 394. 76. All right, and then we have 170 minus 394. 224. Okay, and then I'm going to do the same for 430 minus 394. 36. And last up, we got 300 minus 394. Well, this is the only one that's going negative. Wait. Oh, doop. There. Yeah, you're fine. I'm probably more confused than anybody. All right, so everybody's okay with what we're doing. We found the mean, and now I'm subtracting that mean from each of the values. Okay, so once we have that difference, I'm going to square it, and I'm going to average the result. Okay, so I'm going to go ahead and take 206 squared plus 76 squared plus negative 224 squared plus 36 squared plus negative 94 squared. Divide this by 5 because we're still dealing with 5 elements. Okay, so let me go ahead and catch up to you guys. So I'm going to write this as a whole fraction, and I just blanked on the numbers. 206. So 206 squared plus 76 squared plus, what was it, negative 224? Okay, squared plus 96 squared. Was it 96? 36. Okay. And then 94, negative 94. Okay. So let me delete that. So 36 squared. And then plus negative 94 squared. Okay. Now I'll go ahead and put the whole thing divided by 5. All right. What should I be getting? Okay. 21,704, but Eli is correct. There we go.
Okay.
There you go. Now, this is what we call the variance. Okay? You use the variance to find the standard deviation. The variance is the average of the squared differences from the mean. Okay? So I'm going to take this 21,704. Now I'm going to take the square root, because once you take the square root of the variance, then you have what we're going to know as standard deviation. 147 point what? Let's say 32. Okay. All right, and there you go. Now that's how you walk through the process. That's how you go ahead and find standard deviation. We're going to go ahead and start looking at it with tables to kind of keep things in order. Yes, ma'am.
So,
That's just the average of the squared differences. And there's the keyword squared. That's why that number is so large. Okay. So basically, we have a measure now of how off, I guess, normal, for lack of a better word, is. Okay. So within one standard deviation, you would take the mean, which we got 394, and then you would add and subtract 147. Okay, within two standard deviations, you would add 2 times 147 plus the 394, and you would subtract 2 times 147 times 394. But I'm getting a little bit ahead of myself because I'm really starting to allude to what we're doing next week when we're starting to look at the normal distribution curve. Okay, so right now we're just going to go ahead and practice this. Libby.
Sorry, could you repeat the equation for the variation, like how to put in the variance?
Oh, the variance, it's just the average of the squared differences. The average of the squared distances. Now, there is a formula coming up that kind of simplifies all this, and it uses some math notation that we're going to get to in just a second. I just wanted to kind of do just a simple everyday problem to kind of give you the idea. So is everybody okay with this as far as it goes? Okay. Do you want to go ahead and plug this in the calculator real fast, like we did yesterday on Friday, and see if we do get the correct standard deviation?
Sure.
Okay. Let's go ahead and do that real fast. Now, this isn't a frequency table, so we're just going to go ahead and plug in the data. Okay, so let me go ahead and clear this out, document B. All right, so I'm going to go home. Now, do you guys remember how we do this?
What is the spreadsheet?
Okay, lists and spreadsheets. So I can either click one and then choose lists and spreadsheets, or I can choose the icon down here, whatever you prefer. All right. So you always have to title your columns. I preferably just like to use X and Y, something very simple, but really can be whatever you want. We've talked about this before. I'll go ahead and continue to mention it. Avoid this row next to the equals. That's specifically for spreadsheets, and we don't need to use that. Okay, so let's go ahead and put in, I believe the first one was 600. Then what were the millimeters on the other dogs? Okay, so 470, 170, 430, and 300. Oh, okay, so 170, forgot to push enter, 430, and then 300. Okay. All right, what's the shortcut? I know I could just easily arrow back up, but how do I go back to the first cell? If I hit Control 7, very useful if you have a lot of data. All right, now all we want to do is go ahead and just choose an empty cell. I don't know why. I always like to choose the cell at the bottom right of the very last one I enter. It makes absolutely no difference, but I'm a creature of habit. So I'm going to go to Menu. Okay. Does anybody know where I want to go? I'll let you guide me. Data? No. Statistics. Stat calculations. This is only one variable because we've only got one set of data, one set of dogs that we're looking at the heights of. Okay, so I'm going to push enter. Number of lists 1, so just go ahead and click OK. Now remember, even if it's a frequency table where you put in your class intervals or your data and the frequency, it's still just going to be one variable data, okay, even though you might put in 2 columns. So I'm going to backspace here. I'm going to put in that one heading that we had there. Frequency, we don't have one. And then it looks like my results are going to show in column C. So I'm going to go ahead and click OK. All right. And it goes ahead and gives you a lot more information. Like, did we not find the average height to be 394 millimeters? Okay, there was the sum of all the data. And does this number look familiar? There you go. Now, IB, when it comes down to it, IB does not distinguish between a sample and a population. IB kind of considers it all a population. That's why when I show you the formula in just a second, IB's formula is going to be slightly different than the formula you would be taught in statistics. Is anybody taking statistics in here? No? Does anybody plan on taking statistics? It's a really nice course if you would like to take it. And it's more math, which is a bonus. Okay, but these two right here, there's that little sigma. Okay, the lowercase Greek letter. That's the one we're going to use. Sigma x. We're not going to worry about s of x. We want sigma of x. And then this gives you a lot more information. Remember, there was 5 terms. Gives you all the information if you want to create a Box and whisker plot. Just bringing it up, a little bit of review because the test is on Thursday. Does anybody remember the little expressions if I want to determine if there are outliers in a set for a box and whisker plot? Eli?
Isn't it Q3 plus 1.5 times the IQR,
Yes.
and then Q1 minus 1.5 times the IQR?
Okay, that's very good. Just in case I didn't pick up his voice on the microphone, he's absolutely correct. The upper quartile Q3 plus 1.5 times the IQR, and the lower quartile Q1 minus 1.5 times the IQR. What is the IQR? The interquartile range. Now, is that the max minus the min? That's just the range. Q3 minus Q1. Very good. And Eli, you had your hand up before this.
Yeah.
Yes. S of X is, and this sounds confusing, but that is the population. Okay. But again, I'm not going to go into it in a whole lot of detail because I think that the more depth I go, it just might serve to confuse a lot of folks. And really, beyond what I'm showing you here, you don't need anything more than that. Okay. Any other questions? Okay. So, maybe this Saturday night, you got a nice 3-day Labor Day weekend. If you happen to get together with your friends and you all have dogs, maybe this is a cool activity you guys can do. Because teenagers want to party, right? Yes. Okay. All right. Well, I'm going to get rid of this, and let's start with our notes. Okay. Oh, that is rational functions. You don't want that. We want this. Okay. So standard deviation. Now let's actually get to the notes. Okay, so standard deviation, it measures the deviation between scores and the mean, and is a measure of the dispersal of the data. The differences between the scores and the mean are squared, and the average of these squares is then found, known as the variance. So once you take the average of those squared differences, that's the variance. By taking the square root of the variance, you get what we find to be the standard deviation. And like I said, it's basically a numerical value measuring how spread out your numbers are going to be. The larger the standard deviation, okay, that means typically the larger the spread is going to be between your elements in your set. So what if it's a smaller standard deviation? Yeah, then those elements should be much closer together. Okay, so just like we talked about here. So population standard deviation, okay, so sigma x equals the square root of, now does anybody know what that sigma notation means? In mathematics, what does it mean? It's the sum of, very good. So when you see this symbol, okay, and I can't write it very well, but anyways, this means summation. Okay. So specifically here, this means I'm going to take the sum of f, the frequency, the number of times that particular element appears in the set, times the squared difference. Remember, what was the x with the little bar above it? That was the mean. So x itself just refers to any element in your set. Okay, so x could have been any of those heights at the shoulder for the dogs we were just looking at. And then you go ahead and divide by the sum of f. So all of the terms that you have in your set. Like in that case, we were dividing by 5 because we had 5 dogs. Okay. And then just goes to kind of hammer the point home a little more. You'll notice, is the formula the same? What's the only difference? Okay, one's the square root. Okay, so the variance is just the formula itself, but as soon as I take the square root of it, then I've got myself the standard deviation. Okay, now this is what I was referring to, and I'll go ahead and talk about this more probably tomorrow, but you might actually see these formulas look a little different. Like for example, for any of you who are going to take a statistics class, like maybe you're going to leave here and you're like, wow, that was so awesome, I want to learn more. And you run to your counselor and say, hey, I want to take statistics. There you go, Eli, thank you very much. Okay, you're going to notice there are differences. IB kind of chooses to do things its own way, and then we also have the mainstream mathematical community. So in here, we're going to be dividing by n. Okay, we're going to be dividing by n. But if you were to actually go into a real statistics class, like Mr. Reeves' class across the courtyard, you're going to notice you'd be dividing by n plus 1, which is just going to change it very slightly. Okay, so I'm just going to go ahead and throw that out there, and tomorrow I'll talk more a little bit about why that is. Okay, but just to kind of let you know, because I'm sure a lot of people were really interested in that, right? Absolutely. Okay, so let's go ahead and take a look at another problem. So this one, we're going to start looking at our tables here. It says calculate the standard deviation for this sample, 2546756 by hand. Okay, so these are the elements in my set. And we don't necessarily have to put them in order unless you guys want to. Is that something you'd like? Hillary, you want them in order? Okay. Then help me out. This would be 2. 4. Okay, it goes on. 4. Let me go ahead. 5. Okay, 5 again. Looks like I've got 2 6s as well. And finish up with a 7. Okay. And what's the total of those? 35. Okay. Now remember the steps that we just went through, or kind of refer back to the formula. One of the things we need is the mean, and then we need to go ahead and find what those squared differences are going to be. All right. So if I were to add all those up, it's going to go ahead and give me 35. So the mean is going to equal the total of 35 divided by how many elements do we have here? 7. So my average is 5. Okay. Now the table makes it really easy. It just by column, you're taking it one step at a time. Okay. Now, like before, if you're able to do this without the table, I mean, that's fantastic. But the table just kind of provides that framework to kind of help you out, especially in the beginning, to help you understand what it is that you're doing. Okay. So now I want to take each of these elements and I want to subtract the 5 that we just found, the average. Okay. So 2 minus 5. Negative 3. 4 minus 5. Or negative fun. It's going to be a long year. I will win you over yet. I will do it. It'll happen. Okay, 5 minus 5. So we got 2 zeros here. Next up. Okay, 1, 1, and 2. All right. And then now what? Okay, let's go ahead and square those. So if it's negative, it's going to go positive anyway. So this is going to be a 9. 1. Okay, 0, 0 squared is still 0. 1, 1, 4. Okay, so let's see what my total is. Okay, 9, 10, 11, 12, 16. Okay. So let's take a look at my formula right here. Okay. Well, we want to go ahead and take the sum of those squared differences. Now this, the F, remember, if it's a frequency table, but this isn't a frequency table. I mean, we know what the data is, and we know how many times each shows up, right? So almost in this first one, we can go ahead and ignore that F. So we took this sum right here, 16. Okay. Now I want to go ahead and divide it by the sum of F. So how many terms did I have? 7. Now, 16 divided by 7. Let's see what that's going to give me. Okay, what is that? That's not the standard deviation.
It's variation.
Oh, you're very close. The variance. That's the variance. If I want the standard deviation, what do I have to do to the variance? I got to take square. Oh, square rooted. Okay, I thought we were square. Okay. So I'm going to go ahead and say control square root. I'm just going to highlight the previous one. Push enter. It's going to plug in that whole value for me. Or you can just type in the square root of 16/7. And there we go. So I would say about 1.51. Okay. About 1.51. There we go. So that little sigma x is about 1.51. Okay. And that standard deviation is going to be pretty low compared to the other example we just did, because the lower it is, the closer your value should be, right? And what do you notice about this set? Yeah, they're all a lot closer than the lengths of the heights of the shoulders of the dogs were. Okay. How are we doing with standard deviation? Is anybody having any problems calculating?
I think there's a lot of steps that are going into it.
Mm-hmm.
I think it's
Yeah. It's real easy to make a mistake. Even when you get to the end, it's easy to go ahead and forget that you may have the variance and not the standard deviation. Okay. Well, I'll tell you what. Would anybody like to come on up and show me in the calculator how you'd go ahead and calculate this? We did it by hand. Eli, have you been up before?
Yeah.
Yeah, so I know we will have a lot of other people who want to come up. Okay. So I know those people are sitting out there, man, I really wish he would call on me. I want to come up to the board. Okay, well, don't worry. It's going to be a long year. Everybody's going to have the opportunity. A lot of hands going up. I just need one, besides Eli, because Eli's come up before. I want to go ahead and give everybody the opportunity. Okay. How about this? I'll take the seating chart, and I will just randomly point to a person. Okay, Peyton looks super excited about this. Did you want to do it? Okay, well, let's see. Unless anybody wants to come up here. Okay, here we go. Samir. Yes, we're going to do on the calculator what we just did here. So you'll put in the spreadsheet, the elements, all that stuff we just did. Okay. So let me get over here. Let me go ahead and document B out of this. Okay. All right, so how do we do it?
You need to do a new document you can just click.
Okay.
Then we first have to change this to where's X?
Right there at the very bottom, sir.
There it is.
There we go.
It's
So
the
X.
Don't mess with any of that. Any of the columns.
Okay, don't mess with the equal row. Okay.
Oh, we can change it to frequency.
We can, but it's not a frequency table.
Oh,
So we actually know the set.
that's right. Okay, so. 2, 5, 5, 6.
Oh. Oh, wow. Yeah, that was. Here we go. Let me have you have this. Click, click, click. There we go. Then we had 6 and 7, right?
Oh, 1 more 6.
Yeah, there was 2 6s, right? You go ahead, but yeah, that's right. And 7. There we go. And then you want to click out of that cell.
Yeah.
There we go. Because even though, and again, this is a good point, you've got the number in the cell, until you get out of the cell, the calculator doesn't read it. So it'll come back and say there's some kind of problem. Okay, so we went to...
So then we went to a separate cell, and
Uh-huh.
like you said, the bottom right. And then we click.
And that's what I like to do. I mean, it doesn't have to always be the bottom right.
Then click statistics. So we click menu, then statistics,
Okay.
then stat calculation.
Good.
And then 1 variable statistics.
And this one, just click OK.
Okay. This will be.
Want to delete that.
How do I
And we could click on the right arrow, and it should drop it down, or we could click on the drop-down menu itself.
And then this is not a frequency.
Okay.
So we get rid of that.
No frequency.
That.
It's going to show up in C, and there we go. Perfect. Okay. Excellent, excellent, excellent. And let's go ahead and run through real fast. Did we find the mean to be 5? Yep, the sum was 35. Here is our sigma of x, our standard deviation, which we did get 1.51. Okay, so if we square that, we got our variance. There were 7 items here. And see, this is why I like using this. It gives you so much more information than what you're looking for. So I would recommend, more than anything else, definitely know these keystrokes. Okay, because standard deviation, the mean, box and whisker plot, all of that stuff is right here. And in fact, in a week or so, when I start showing you the correlation coefficient, you're going to be able to get that with this same information as well. Okay, so there's going to be a lot that you're going to be able to get. Is anybody having a hard time? Any questions? Are we not sure about anything? Okay. All right. Well, I've got going on 2 o'clock. Let's just see how much further we can get. Okay. This wasn't a very long lesson. Okay. All right. So let's go ahead and take a look at this one right here. Now, this one is a frequency table. Okay. So it doesn't change anything, does it? Okay. There you go. Now, with the formula, you do want to go ahead and multiply the sum, or excuse me, the square difference by the number of times that particular item appeared in the set. Okay, so for this one, we definitely want to use the F because it's a frequency table. See, the last time we didn't bother because it wasn't frequency. All right, but for example, how many times does 11 show up? Okay, 3. So if you were to actually write it out, 11, 11, 11, then you would have 4 12s. Okay. And then, yeah, you're going to end up writing a list of 50 terms. And so a lot of times using a frequency table is just a way of kind of shortening that up so you don't have to write as much. But again, I just want to drive home, what frequency is referring to. Okay, so let's go ahead and run through this, and you guys are going to help me out. In fact, why don't we get somebody up here? Somebody else. Let's do this, because there were so many volunteers last time, I can't decide. Samir, you were the one who somewhat volunteered to come on up and help me, but you did a great job. Who would you like to see come up and fill in this column? This is where we find out who our friends are. Yeah. John Johnston. All right. John Johnston says, I accept your challenge. And your classmates here can help you out. Okay. So that's 33. There you go. And I got my marker right there, sir. Oh, my handwriting is much worse, so don't even worry about it. Even a chicken will look at my handwriting and go, dang, that's bad. Really? Nothing on that? You ever heard of somebody's handwriting described as chicken scratch? Because it's just like they took their claw and went. Yeah. Okay. Okay. Okay, so let's see what we got here. So 33, 48. What's that third one there? Is that a 65?
Yeah.
Okay. 28, 120, 144?
Yeah.
Okay. Then 85, 144. Okay. And finally 19 times 6. Oh, let's just click the screen. There we go. There we go. Click. There we go. Click, click, click. It's still around that 1. I don't know what it is. Here, let's see if we just click it itself. There you go. Click, click, click. Okay, try writing and see what happens. There we go. So we're looking for 114. Good. 114. Perfect. All right. We'll go ahead and have one of them do it for us. So he got the product of all those elements, okay, individually. Now we need the sum. Okay, so 33 plus 48 plus 65, all the way through the 114. What am I looking at? 781. There we go. Perfect. 781. Now, what do I need to do in order to fill in the next column? I need something. We got to get the mean. That's why we took the total of all those products right there. Okay. If I were to add up all 50 of those terms, I'm going to get 781. I'm going to divide by the 50 total that we have. And let me go ahead and catch up to some folks out there. 781 divided by 50. What am I getting? Let's say 15.62. Okay, 15.62. So that's going to make this not as quick. It's not difficult, because you could still have a calculator, but, it depends on how good you are with decimals. So I'll go ahead and say 15.62. I don't know if there was any more digits to that. Okay. But now for each one of these, I need to find the difference. Okay. So this is the term. So this isn't the 33. What do I do? Okay, this is the score, so the actual elements in your set. So for example, I need to know what 11 minus 15.62 is. So maybe this is going to be the best way. I'm going to go ahead and say 11 minus 15.62. Okay. Negative 4.62, and then I can square that. Maybe go ahead and get both those columns at the same time so you don't have to go back and retype all that stuff. Okay. So the answer squared. There we go. So negative 4.62. And then I believe we had 21.3444. 21.3444. And see, this is one of the things, I mean, you know, we're doing it by hand, but you want to try to get your answer as approximate as possible. What's going to happen if during the process, I go ahead and just round that to like 21.3 or a negative 4.6? Yeah, could that affect the outcome? So that's why I'm more willing to go ahead and take those decimal values as I go along, so I can get that much better of an answer. So our answer might be slightly off when we go ahead and do this on the calculator. We can go ahead and do that if we wanted to. So now I'm going to take the 21.344, okay, and that 11 showed up 3 times. So I'm going to go ahead and multiply that by 3. Times 3. So 64.0332. 64.0332. Okay, now here's what I'd like you to do. You don't have your homework assignment yet. I'm going to go ahead and give that to you later in the week. But does everybody feel like they're getting a pretty good understanding of what we're doing? See, even this right here isn't bad. You know, just get out a calculator, maybe 5 minutes. I want you to go ahead and finish filling in this table and seeing if you can determine what the standard deviation is. And I'll go ahead and show you very quickly. I already had the table filled in. Boom, right there. See? So I've already done it too. Okay. So, I mean, even if you don't go home and use the calculator, maybe you can pause it at just the right second, and you'll have that table, everything you need. At the very least, people will be going and watching the video, right? So it's win-win. Okay. So I got 2 minutes. Guys, you did a great job today. I thank you very much. Can we get those calculators back on the charging station before I let you go? Now, I will be here in the morning, 7:45, if you have any questions. Okay. Yeah, more than likely, I would say let's take the test on Friday. Jerry, on Friday? That'd be great. That'd be great. If you could shoot me an email just to remind me, because I'm horrible about that stuff. Thank you very much. Oh, yes, if you have your focus activities and you want to go ahead and turn in all 3, staple them, put them in 6 periods straight. Otherwise, tomorrow is when I'm going to be looking for those. You only have 3. Only have 3. Oh, I never stopped.